So far we talked about what is networking, then we talked about layering. Why is the layering important? So as we learn keep through, so we know that it is not possible to understand the full stack of the network and do designing on one part. So rather than doing it, so I can understand my part, then I can handle how to up and down in the view of the layer. Then your programmer's jobs is much simplified and it's easier to do. Then we talked about how we measure your new design of the system, new design of network. Then we talked about why is inefficient just sending a bit as a 1 is a 1 and 0 is a 0. We talked about why is it inefficient. Then what happened if it goes wrong? How can I overcome it? Then we talked about error correction. Then we talked about how can we retransmit. So what is the opportunity to retransmit it that we talked about? I said, what if there's multiple guys, multiple access, right? How we handle it. Then what happened? It comes to the wireless. It shows a different characteristic, something like a hidden node and something like exposed node. So we talked about 802.11 in more specified Wi-Fi. And we talked about how they are connected. So between them. So network per network, how they are connected. So we call internetworking. So acronym for the interconnecting is intra-networking. And we talked about how my packets are travel from point to point. Point to point means in the view of the internet. So we talked about more deeply about transport routing. Then today I want to talk about the policy-based networking. So we learned so far, okay, in the routing, DSDB, DSR, AODB, and all these things. So OSPF. You know what? Then how does it really work? Is it the OSPF? All these things are really working in the field? That is not true. Why is it not true? Because actual networking is so big, and the networks are used and being handled by the company who's pursuing their own interest. Meaning, if the Samsung has their own network, they don't want anyone else coming into their network. Okay, and if the KT is handling their own network, they don't want SKT is coming into their network. So they don't want to handle whatever the traffic comes from SKT. They just want to ignore it. Then we call the policy-based. Who made the policy? The human. Okay, so they need to keep the very basic protocol, but what they do is completely based on administration's policy. Okay, we're going to talk about this. So routing on the internet, there's a scale issue. If you're using DSDB, DSR, AODB, we have to keep transmit. And it is impossible to have a global view of the internet. Okay, we living in 7 billion people living on Earth. Maybe 50% of the human being have the IP network, and about 10% of them have more than 10 devices. Okay, then it is impossible to do that. So we have to solve scale issue. How can I keep expanding our network? So network of IP prefixes indicate a different subnetting. So IP prefixes, who's an A class, who's a B classes. So if the IGC has a one IP sub prefix, then they are dividing subnet to the one goes to the SUNY Korea, one goes to FIT, one goes to Utah, one goes to George Mason, one goes to the GET. Okay, so far there is more than 200,000 subnetting. It's too many. We cannot handle those. The router has no ability to understand 200,000 configuration. Okay, so more than 20,000 organizations owning different subnet. Let's say KT has it. One goes to SNU. One goes to the KAIST. They should have a completely different router. They should be completely different subnet, right? So KAIST their own has intranet. So in between them, internet. So if the network comes to KT, So they should separate, completely different. Okay, and in the world, millions of different routes between and within the subnet. So in the case, how many computers there? Maybe 100,000. So how they connect it? The combination is so many. It's not possible to have it. Okay, so privacy issue. So organization may not want to reveal internal topology. Okay, let's say one of them is Samsung. They want to keep their secret as deep as possible. So if the new packets are coming in, if they have to handle the routing, they're never going to expose it because it is highly related to the security and the survival of the company. It depends on. If the one of the computer is breached, then the top secret information will be leaked. They don't want that to happen. Okay, and policy issue. So there is no unique policy for determining cost of link. Oh, so my network told me this is the best path, but it turns out it is not. There must be multiple hops, but better. Why? Because this guy is an evil. They don't want to forward the packet. They don't want to spend their energy to delivering to someone else's packet to the others. They don't want that to happen. And organization may not prefer the route based on the policy relationship. Let's say this is Samsung, and let's say this is LG, and they want to connect it to, let's say, IBM. So IBM has a good relations between LG and Samsung. But let's say LG is in the middle. If the packet is coming from Samsung, they'll just ignore it. They don't want to service for the Samsung because they are a competitor. They don't forward it, but rather than going to this way, they prefer to go to this way. Samsung also don't want to expose, oh, I'm communicating with the IBM. I don't want that. I don't want to do via LZ. Okay, so organizations may not prefer or may prefer the detour based on the policy and relationship. If the LG and Samsung is such a good relationship, they'll prefer to communicate. If not, they don't want to. Okay, who make decision? People do that. Okay, so we talked about, okay, so all the algorithms, and in reality, it run by the human and run by the policy and run by the business. Okay, so we called AS is autonomous system. So AS is a set of router that has a single routing policy. Something like it runs in the KAIST, runs on the SUNY K. Let's say SUNY K policy. SUNY K policy is if the packets are coming via IGC, they're accepting. If the packets are coming from the Ghent, let's say we have very poor relations with the Ghent, then I'm keep ignoring. So as a one entity, we are AS. So how they handle inside? Okay, from CSE department, from ME department, how they handles? We are mostly friendly. Then how do we connect it with the others? Let's say in here is a Yonsei. How we connect them? So border gateway protocol. So internal gateway protocol. So how do we handle internally? How we handle externally? So in between. So IGP is Internet Gateway Protocol. So internal gateway protocol. So internal routing policy, but within the AS. So internally in the SUNY Korea, how they handle. So routing between AS's relations with the Yonsei is based on the relations between Yonsei. If we are good, then we will be very friendly. If not, we want service for them. So external gateway protocol at the early stages of internet. So they called BGP. So concept of it in between. So external, internal. So internal. So we called the BGP because they are border gateway protocol. Okay, so type of ASs. We have many types of ASs, and stub AS, multi-home AS, transit AS. The stub AS is the only single connection to one others. I have only single connection to other. So it carries only local traffic. And multi-home ASs, meaning more than one ASs but refuse to carry. So more than one ASs are connected. More than one AS connected. More than one ASs are connected. Okay. So larger corporations, something like a Samsung, they are not serviced with the KT, but also they are maintaining SKT and KT. Okay. So transit AS is AS that connection more than one AS and carries both transit and local traffic. So let's say it is KT. KT has many subnet, and how they connected? They are connected to the Japan. They are connected by the China. They are connected to US. And how they handle it. So internally, they are also very complex. Okay. So drawback of the link state is distance vector routing. So we talked about in the last class. Oh, we talked about link state as distance vector. Okay. You know what? In reality, this is not working. Why? Because it is a business. Okay. And the data traffic is restricted to the shortest path route. So link state and distance vector are preferred to go to the fastest possible. Then choose always the shortest path. So not all nodes may assign the same metric to the link. So if I have a clear view of the network, it is possible. But people don't provide a clear view. They don't want that to happen. Because if your enemy knows your network configuration transparently, meaning you are very vulnerable for the attack. So it is difficult to obtain the same global view of the internet. Samsung, let's say Samsung admin and LG admin. So Samsung admin has a global view of the Samsung, clear view. LG has their own, but they don't want to expose their clear view to the LG. So they are giving different information. Okay, I think I have one. What do you mean I think you have? Okay, so they are just giving the smallest possible information to the others. So LG is hard to configure to Samsung, so they don't trust. It is difficult to obtain the same global view of the network, okay? And conflicting information may lead to routing oscillation. Meaning, oh, can you serve this? Okay, I will serve it. But you know what? In the next time, I'll not serve it. Okay, something like that happened. So topology information is flooded the entire network. So by using link state and distance vector, my configuration information is flooded all over the network. They don't want that to happen. They don't even want to expose it, and they don't want their information is flooded all over the places. And high processing overhead at each node to determine appropriate right. Meaning, okay, can you give it to me? Rather than process it and make a decision, I just decline it. Why? So receiving, I have to decoding, I have to make decision, meaning that also take computation power. So those companies don't want to do that. So let's talk about the path vector routing. Path vector routing, we talked about link state and distance vector. Path vector is more close to the BGP and IGP and policy-based routing. So key idea of the path vector is advertise entire path to a destination rather than cost of path. Okay, meaning, so let's say I'm traveled from here to here. What do we done before? So we talked about, what's inside of it? How long is the latency? So if I'm worried about the latency, I'm only collecting the latency information. But you know what? So just deliver the AS information. That AS information, I already have information on it, detailed information. So path vector, advertise entire path, 4, 3, 2, 1, rather than just cost of a path, cost path. So have a more higher view. So it is based on the distance vector algorithm and send cost metric to the destination along with the entire routing path to the different ASs. So if I'm advertising my path, I am AS4, here is my detail, then deliver to AS3, then AS2. AS2 deliver to AS1 is, I've been through this path, okay? So advantage of the path vector routing is it can easily detect the loop detection. Why? So it is actually inside a very complex. Inside it, there is very complex, multiple routers connected. But I don't really care about what does it look like internally, but I do care about both BGP, what's on the border, what's on the border. Therefore, I don't need to compute all detail, but I only compute the bigger view. So my computation power doesn't need to be complex. Okay, it doesn't need to be heavy. I can just handle it because AS's size is big. And node can simply discard the path from the loop, meaning if the path is coming via this way, 1, 5, 4, so it comes from 4 and 5 and 1. If the packets are coming via this way or via this way, so if the original packet was 4, I can discard it because I already handled it. Okay, so flexible policy implementation. So each node can apply local policy. Here's my Sunni Korea policy. Sunni Korea policy basically accept all from SBU, decline all from, who's our enemy? Let's say Yonsei. I'm sorry. So basic policy, accept all packets, all traffic from SBU, and decline all from Yonsei. This is written rules. And which path to use it? If I have to connect it to the out of Songdo, let's say we have a multiple BGP. One is handled by Yonsei, and one is handled by the IGC. Then I always prefer to go to via IGC. Okay, so here's my information, and here's my periodic traffic. Rather than advertising everyone who's near here, I'm only advertising IGC. IGC, hey, I want to talk to you. Here's my updated information. Oh, thank you. Then IGC will provide. Hey, Yonsei, hi, I'm here. Can I ask your path? Then I think I'm just working. Don't worry about me. Something like this. Okay. So example. Node 2 may prefer to, when node 2, AS2 wants to talk to A, this path is clearly better view. But they don't want to happen, but they want to go to here by here. So even this multi-hop, even it's a longer path, they prefer to go to this way. Okay, so it is very common cases. Let's say AS2 is sub network. Let's say it is a Sunni K. And let's say it's IGC. Let's say it's Yonsei. So Sunni K has a weaker defense mechanism, but IGC has more powerful, and I have a group relationship with the IGC. So I trust IGC. So then talk to Yonsei. And Yonsei talks back, meaning IGC handles if there's any fault, then they will forward it. It is more hops, but it's path through to someone who I prefer. But if I talk to Yonsei directly, I'm exposed myself. They don't want that to happen. Okay, this is very common case because it is a business world. Okay, and BGP, Border Gateway Protocol. So interdomain routing protocol for the internet, and it has prefix-based path vector route, path vector protocol. So we're going to talk about what is prefix-based, and it is policy-based routing based on AS path, and evolved during the 15 years. And the BGP is the routing protocol that what we are using, okay, what human beings are using. So AS1, AS2, okay. We open the BGP session, and based on that, so our packets are handled. So it is basically established a TCP connection on port 179 and exchange information on all non-active routes and exchange incremental updates, meaning initially they handshake every information they have, but periodically update their all information is not necessary. Sorry. So they are, oh, here's my update. What has changed? Hey, here's what update. What has changed? So only updates the incremental updates. Okay, they don't need to handle everything together. So periodically, so full update is about the one per quarter, meaning every 3 months. they do full update, but in between, they only handle the incremental update. Okay, and storing and learning route. So BGP route stores a multiple routes toward the destination. Okay, because we have a multiple ASs, and there's a policy and apply for the selection of the best route. How do you determine what is best? Okay, based on your business relationship and based on the network performance. So we thought the network performance is #1, but in the business is more prior than the others. Someone I can trust or not. Okay. So whenever I advertise my information, I also select whom should I talk to first, whom should I notice my information. And incremental updates, announcement and withdrawal. So announcement and new active route toward the destination are updated by sending BGP update. And withdrawal, if the route is no longer active, meaning something goes down, and withdrawal information is sent to all neighbors. Okay, so it is a basic rules everybody has to follow. If something goes withdrawal, meaning I can send all my neighbors, but if something is new, then I can send only my preferred. Therefore, the basic network is working, but some of them has outdated information. Okay, so by using this, there was a huge attack. So we are just sending withdrawal to everyone. Withdrawal information. Then the many routers goes down. Actually, it does not goes down, but they receive that routers goes down, and that traffic is go different way. Then they're creating bottleneck. So network is accepting this withdrawal information is very risky. So rather than doing this, they examine. Okay, let's say SUNY, okay, and FIT and Ghent. So SUNY K is a player, and just advertise, hey, FIT goes down to the Ghent. Oh, Ghent, oh, really? Then next time I should reroute to every node goes to the FIT. Okay, then so SUNY K told me, oh, you know what? I know that I have a internal connection to FIT. Therefore, if you have something to FIT, just talk to me first. Then SUNY K hijack all the packets. Okay, this is very basic hacking mechanism. But what they do is, hey, you tricked me before. Then, hey, FIT goes down, meaning, oh, thank you. And Ghent is asking again, oh, FIT, are you okay? Were you fine? Are you fine? Then I'm fine. Then they keep ignoring. They will ignore. Oh, something wrong on the SUNY K. Something is compromised, SUNY K. Okay. So routing in BGP. So destination prefix based. This is prefix 16. We understand what is 16. 8, 8, 8, 8. The subnetting, right? This is IP address with the subnet, meaning the 16%, the 16 bits are network, rest of them are the host. Okay, so this is how we using. So we call this prefix based, includes route paths such as next hop as ASs. So if the destination is this guy, 128, 122, 56, and 016, so destination is specified in every packet. So let's say AS3 wants to talk to AS1 via AS2, okay, because I have updated information. So this is my destination and how we connect it. So and the middle guys, AS is a bigger view. Hey, using AS2 and AS1. And this is my next hop. So this router has updated information and knows who's next, and tell the next node, hey, don't compute this, just compute the ASs. Oh, I am AS2, I ignored, I computed, then handle to AS1. So handle to AS1, So AS1's prefix is 192.168.0.5, the prefix. Then AS1. So it goes to the AS1. Okay. Hey, here's my destination. It's the internal of the AS1. There was 128.22.56.0 with the 16 subnet. Okay. So what we done previously? So we talked about the hierarchy and next hop, who's next hop, who's next hop, right? That information is too long. Hopped. It looked like only 3 hops, but internally there are many computers. So if I do with the distance vector from here to go to there, and go to router, come to router, hop, router, hop, then hop. Hey, here's my final destination. We faced more than 10 hops, which is not necessary. So what do we do? Hey, here is me and want to talk to this guy, meaning I have AS view, go to there, router, this is AS to AS, then I don't need to, I can ignore all the internal. Hey, go to the BGP from here to here. Oh, this is for my ASs. Internally, I will handle this. Okay, therefore we need AS path, then I can jump bigger. Then I have to know who's my next between router to router in the BGP. Okay. So BGP attribute, it has AS path and next hop and local preference and multiple exit discriminator. AS path meaning sequence of ASs that a route has traversed, the bigger view. So used for detecting loops and applying policies. So if I have a loop, meaning I have to check all the paths they've been through, rather than doing this, I have a bigger view. Because I don't hop in detail to detail, but I hop BGP and BGP. Okay, therefore I can detect the loop quickly and I can check the policies fast enough. Policy is something like if something goes from AS3, deliver very slowly. Or if the packet is coming from AS3, deliver is fast enough, very fast, fastest I can handle. Okay, next hop information is next hop to reach a network. So the router to router, I need to know the next hop information and local preference and used to the influence the selection path. Selection of the path used to influence the selection of path with the highest local frequency is selected, meaning I prefer to go to the IGC much higher than go to the Yonsei. Okay, multi-exit discriminator is used to influence the X point with multiple BGP routers exist in an AS. Let's say in an AS may have different BGP. Then which one should I talk to? If I want to talk to this guy, I should talk to this guy. Okay. If I talk to this guy in the all the way west, then I should talk to this guy. Okay. So I have to maintain some level of information. So ASs may have multiple BGPs. Okay. So BGP path selection is follow a minimum hub approach, basically minimum hub and shortest AS path. And if there is a tie, just break it in arbitrarily. So for example, AS2 to AS6, let's say here's AS6. If there is AS6 all the way right, I should go to the AS3 first. Okay. So if I want to talk to someone in the AS6, then I set AS3 and 6, this path, and next hop is this information, meaning, so I am AS2, my next hop is this interface, and discarded is sequentially AS3 and AS6. AS3, then go to the AS6. But by having path information in AS view, I can quickly detect the loop, and I can quickly detect the make a decision on the policy. Then here's my final information for my view. This is my next hop. Let's say what is the AS3 does. So let me write down in here. So this packet looks like, let's say it is 10.12.1 123.5 network. So destination is 128.122.56.0.16 AS path. So I mean this AS path is AS6 because AS3 is just computed. And next hop is 10 dot this guy, 12.123.5. Okay. So by looking at it, we have ability to fill out what information needs to be delivered and how the packets are set it. So BGP policy, we can do import and export. Import the policy is filter unwanted route from a neighbors. So let's say I have a very good relationship with the SUNY K, very good relationship with FIT, and very poor relationship with the Ghent. So filter unwanted route from neighbor. Ghent, whatever Ghent talk, I can ignore that. Okay, so prefix that customer doesn't own. So we are one team, but you are not. Okay, then manipulate attribute to influence path selection. So FIT gives me their information. I trust it and deliver as fast as possible. If they can't give it to me, keep giving to me. Okay. So I keep ignoring. Then I think I have to open it because they are asking so much. Then I can say, okay, I manipulate. This Ghent path is so poor. I make the score the lowest as possible, then deliver to the others. Okay, so I can influence the path selection for the others. Therefore, whoever wants to be connected by Ghent should come to me first. Then I can start opening it and I can play with it. Okay, so how to import it? That's up to the admins, the preference. Okay, and export policy. So filter route. You don't want to tell your neighbors, hey, I want to talk to FIT, all my details, but I don't want to talk to you to Ghent. Okay, so don't tell the peer route, learn from other peers. So if I have the whole network, then let's say I know everything, but I'm not telling Ghent all the details. Why? I don't want to talk. You are not my business partner. Okay, and manipulate attribute to control what they say. Okay, let's say I know this information and Ghent is like officially asking by CCing someone I have to reply. Then they are giving information which is like outdated information or wrong information. They manipulate. This is the business wall. Router is business wall. Okay, so import the policy is local preference. So favor one path to the others. So let's say if I want a AS1 connected to AS4, I have multiple BGP. One is T-Mobile, the other is Sprint. Let's say something like in Korea is SKT and KT. I know I have 2 subscriptions, but whenever I want to talk to AS4 and I'm paying less money to KT, I'm paying higher money, meaning I prefer to go to the better service, even if it goes multi-hop. Even KT has a better hubs, so I'm not using this. I go this way because I pay more money to SKT and I trust SKT better. So we call it local preference. Local preference is high, I deliver to them. Okay, the path doesn't matter, the business matter. So favor one path over another. So used to override the shortest AS path principle. Oh, you know what? Your shortest path tells you the AS544 is a better route. Forget about it. I prefer to talk to the T-Mobile first. Okay, something like this has happened. And it is very common in the business. And if I have experience of the breached, meaning my network was attacked by the Sprint route, you know what? I don't want to talk to you because you had some history on it. Okay. Filtering. So filtering meaning, so discard a certain advertised path and recognize network or AS based on the prefix. So discard route or contain large ISP, and discard prefix is not on. Okay. Let's say SKT and KP and LGT. Let's say I'm subscribing 3 of them. KT has the largest, and LGT has smallest, and SKT is medium. So if the path is known by the largest one, LG, under the KT, then I understand it, thank you. Then everybody advertise to them. So you know what? Rather than talk to the largest one, meaning they have a better network, bigger network, then also the delay is longer. So just talk to the LGT to escape the packet out of the Korea quickly. So LGT's configuration is much simpler. Then there's a less vulnerable point. Okay. So discard route that contains a large ISP, and discard prefix that is they don't own. Okay. So let's say I am the Samsung. Let's say Samsung owned some portion of SKT. They much prefer to go to the SKT. And export policy. So limit propagation of the routing information. Don't announce route from one peer to another. So let's say I learned so many things via different network entities. And whenever I want to advertising, I'm giving different information to SKT, LGT, and KT. Why? Yeah. Okay, so they don't want to expose their whole information. Also, they want to impact their role to the neighbors. So don't announce the route from one peer to the other. They are not just forwarding. Don't advertise routing contains untrusted ASs. Okay, let's say this is untrusted one. So in the view of the Samsung, what it could be, so Samsung, or let's say Hyundai, let's say Tesla company. So Tesla and Samsung has some issues with attacking and defensing. So they don't trust each other. So if the packet information and route information learned from Tesla, they just discard it. Why? I don't trust you. Okay, then they don't advertise it. And that is good policy. If someone is not trustworthy, they don't deliver to the others, meaning the bad information not propagate, not announced to the others. Also, it could happen if it is a good information, they don't deliver to the others. Okay. So it is like a two sides of the coin. If there's something good, there is something bad. Okay, manipulating other attributes to influence the way the other ASs perceive route. So what should we have? I should have own mechanism. Okay, is it telling me a lie or is it telling me the truth? I should play at all the time. So BGP policy configuration. Then how does this policy is configured? The routing policy languages are vendor specific, meaning the language itself is different. So it is not part of the IGP protocol specification. And different languages for Cisco is Juniper, who's making routers. And still all languages have some features, something like policy as a list of clauses, and each clause matches on attribute. And either discard or modify the matching route. They have some common key features, but it is all different. Even the language is different. Okay, so now Cisco is a #1 and the winner of the router. Now in the world, Cisco is #1 and Juniper was gone and Nokia and Huawei. So Huawei was near the Cisco, but you know, the conflict between US and China, and they goes down. Okay, money, the relationship work and money works and business work, also the power game works. So policy is a list. This is common features they have, and it is all configured by the human operator. So in an IGC, policies are written by the IGC human, the admin of the IGC. So implementing the policy of their own ASs, and it is done by the business relationship, traffic engineer, and security. Okay, all this information determined. So other considerations. So AS paths can be misleading in terms of delay and number of hops. So AS path, if I want to talk to AS1 to AS3, so if I go to this path, path 1, if I go to this way, is path 2. Okay, path 1 goes to BGP, and this BGP has no direct connection to this BGP. It should have, but it doesn't. So it goes to hop to hop to hop to hop, then deliver to this information. But this one is path 2. They have direct connection to BGP to BGP. The BGP to BGP, the path is much clearer. Even it is the same 2 hops, AS1 to AS3 is 2 hops, right? But it could be completely different. So in the view of the ASs, sometimes it is very confusing. So because we don't know what it look like internally, and they are not giving me the clear information. So you have to think about this, okay, when you are setting the your AS paths. Okay, so treating multiple routing within the ASs. So BGP, we know what the BGP, and we distinguish between E and I, external, internal. So how we handle the external? So BGP to BGP, eBGP to eBGP, eBGP to eBGP. So how can it handle internally? So BGP routing information is disseminated within an ASs using iBGP, new concept. So eBGP is what we learn about, is a BGP. So you know what? So in the BGP, I have a multiple BGPs. Then how they handle if they are within the AS. Okay. So let's say it is eBGP and iBGP configuration. So whatever the information is coming from here to there, let's say it was 18.0, 16, 12.5, 24, D was 128, that is total 16, is 128.69.16. Okay, so IP address itself is hierarchy, and if the packets are periodically and consistently coming from this way, meaning A's handle these prefixes, D handles these prefixes. Whatever the packets comes with this prefixes, prefer to come via D. Okay, so BGP table for the AS, which is our eBGP. So prefix is matched to border gateway. Prefix is marked to a border gateway. Okay, let's say D has this prefix. Whatever that comes to D is prefixed with this one. Okay, this could be multiple, like A. If the prefix is coming via this way, it could be, so it's a BGP table for ASs. And let's look at the router table B. So I want to talk, if I have friend of A, C, E, D, if I want to talk to A, I can directly talk to A. If I want to talk to C, I can directly talk to C. If I want to talk to D, I should talk via C. If I want to talk to E, I should talk to via C. Okay, so in the view of the B router, if the prefix packets are coming this way, 18.0.16, where it is, here it is, the packets are coming via E, then whom should I talk to first? You should talk to C. Okay, so 12.5.5, which is this one. Then if we want to talk to this prefixes, whom should I talk to first? A. Oh, okay. 128.34, this guy. Then whom should I talk to first? C. Okay. 128.6.9, this guy. Whom should I talk to first? Okay, I should go to this way. A. Clear? So we just learned how we set the routing table for B and how the eBGP look like and iBGP look like. Okay. Any question about this? Too easy? So, and there is a hot potato routing. Hot potato meaning, oh, it's too hot. I'm handling this one. I'm handling this one. I don't want to hold it. Meaning, get rid of packet as soon as possible. If there's something coming in, rather than compute which one is free for row, don't do that. Just deliver to the others as fast as possible. That is hot potato reflection. Hot potato routing. We call it deflection routing. Incentives minimize required storage and probability of the buffer overflow. Meaning, if there's something is coming to me, what I have to do, I may discard it or I may deliver to the others. So basic information is if I store and forward concept is store and deliver, right? Whenever I do that, store require my storage users. Deliver to them, I require computation. Unless I have a huge storage, whatever comes in, I just deliver to the others. I don't want to hold it and it just occupy all my storage. Okay, I don't want to compute that. I just want to toss it to my neighbors as soon as possible. So key concept is get rid of packets as soon as possible. The packets, they have preference, they have optimal path. Oh, no, don't do that. Just keeping in and just minimize the computation I need. Then I just hand it to the others. Okay, that is hot potato routing. So if the two packets must go on the same side, I don't do that. I don't do that in here. So whatever it comes in, why is it not possible? If the two packets are coming, it must be delivered by one path. Oh, you know what? It is delivering. Let's say delivering this is much preferable. Keep delivering takes too long because I'm keep feeding to the one line. Rather than doing this, I divide it to the half and keep delivering in the same pipeline. I'm just giving to the AS2. Okay, whatever it comes in here. So I'm only think about how to forward it as soon as possible. I divide it to the half and deliver to the one path. At the same time, I'll deliver the rest of it. Okay, that is hot potato routing. Okay, any question about today's class? No? So this is end of routing. Policy sending in a second. So I want to move on to one layer up, which is our transport layer. So we talked about 7 layers of the network. In the middle, we talked about physical layer. So how the 1 and 0s are represented, and how do you 1 0 1 0 represented, and how to make efficient routing, meaning how to make a robust routing. Then rather than just 1 0 1 0, I'm making NRZ or Manchester coding. I make it longer. Therefore, I make more distinguishable pattern. Then we talked about MAC. What if, how you handle if I have multiple things that are coming in? How do you handle it? How did you retransmit it? Okay. Then how we talked about routing, how the packets are traveled. Now it is transport layer. How do you handle? How do we deliver end-to-end communication? Okay, that is transport layer. So internet architecture, we talked about this, right? I have either a network with the Ethernet, I may have fiber optics. Okay, there's IP and TCP and UDP, and here's your application. Okay, so this TCP is the winner in the business, but the basic concept, theoretically, UDP is a superior. Basic TCP concept is make a secure connection and keep changing my window. Window meaning the packet size. How big is the packet size as necessary? Okay, UDP, they don't shake hand. Okay, but doing best effort. This is what I can do best. This is what I can do best. They don't have handshake mechanism. So TCP is known as industry winner, but today most of traffic runs by UDP. Do you know why? No participation. Chrome, okay, perfect. So Chrome is based on the UDP. Then how they do, so let's talk about this for a second. So let's say I have TCP and UDP. This is industry winner. This is today's winner. Until 2018, this overwhelmed the business. But after 2018, UDP is a winner. Basic TCP is handshake, and the window size, the packet size, keep transferred. Oh, this is better. Can you handle this? Can you handle this? If not, reduce it. Keep changing and adaptively keep changing it. Okay, but they don't do handshake. But like David said, based on the Chrome, we are using Chrome, the Google Play. Okay, why is that possible? If you think about the access to the internet, what do you use as an application? I use YouTube. I use Google. And maybe I use Facebook. Maybe I use Instagram. Maybe I am using 7. So where's the majority? YouTube is about 80%. Google about 15%, 2%. It depends on your preference. Okay, let's talk about YouTube. So I have to keep through what is the best rate, what is the best delivery of my network. But I'm using Chrome and Access YouTube. They're all from same company. So my computer and Google YouTube server, they already know their status. Why? I open the Chrome, then access to YouTube. Open the Chrome, access to YouTube. Chrome caches all information they need to know. Okay, Chrome collects huge information, all detailed information on your computer and deliver to YouTube. And YouTube provides that the handshake is not necessary because I already know your status. Therefore, the Chrome, we call it quick. So this is a protocol for the Google. It is completely UDP based. It is possible because they already cached your information. Okay, then UDP is today's winner. So quick traffic. Quick traffic proportion. So Kik accounts for 7.8 of the total network and 98% by the Google in 2018. And 2000. So 2019, 42%. And it has keep increasing. So if you look at in here at the top, 98% is contributed by Google. So I'm living in a Google's umbrella, right? So you are using the YouTube and what we are updating on the YouTube, and we are living in the Google's umbrella. That is why the UDP won. UDPs keep winning. Okay, let's look at the acronym, the terminology for the FTP. We know what it is, File Transfer Protocol. And TCP is Transmission Control. UDP is a User Data Frame Protocol. HTTP, TFTP, and DNS and IP. I think all the terminology as we have talked about. And this transport layer is end-to-end protocol. What's the difference between end-to-end protocol and the previous? Previously, we talked about router to router. We really care about the next hop. What is important to the next hop? From now, transport layer, we talked about end-to-end. Is my package is actually delivered to David. I don't really care about in the middle. I do care about, is it really, how fast is it delivered to the David? End-to-end. It is responsible for realization and host-to-host packet delivery. And service of the transport layer is guarantee message delivery. End-to-end, meaning if it is not delivered properly, I'm sending again. Okay. And order delivery. If I'm doing a live streaming, the order is really important. In rejection of the duplicate message, if the message is coming twice for the same content, this transport layer is responsible for rejecting it. And message of arbitrary length, that is fine. I can handle it in this length, this layer, and the congestion control to handle network overloading. So if I just keep sending to the David won't be able to decode everything. So I'm controlling size of my packets. Okay, how about that? Then he digested in feedback and sending a little bigger one, a little less one, and bigger one, less one. Then we call the congestion control. Because David is keep digesting. Okay, how do I make a size? A little bigger is fine, or smaller is better. Something like this. Keep changing it. Like keep adapting to the congestion. Okay, then we call the congestion control. And running of a multiple application process at the same host. I don't need to rely on one path. I can deliver from me. I don't care in the middle. I just want to deliver to David. Keep sending a different information, then they may take a different route. But it is actually delivered to the end-to-end, David or no. Okay, then I can send multiple applications. So let's say the Google established me to Google established okay, here's my laptop. Let's say this is David watching a YouTube. Okay, YouTube server from here. I'm watching it. I don't need to watch one, but I'm dividing to half screen and I'm watching YouTube 1. Let's say this lecture. At the same time, I'm watching a BTS music video. Right? So I could have multiple processes. That's fine. What I do care is end-to-end. Is the package actually delivered? Oh, I can divide it to 4 screen. I'm watching BTS. I'm watching small lectures. And I'm watching different music video, different game. Okay. So why do we need to understand? Why do we need the transport layer? So network itself is limited. Limitation of the network layer, the lower layer, T and N, right? The lower layer can drop the messages. And router may incur the buffer overflow. So in the middle, something dropped. something dropped. They don't really care. Is it? They do digest or no? They don't provide a feedback. So if I receive the packet, missing it, a packet, so something is gone. So I should ask again. Try it again. Okay. The order also handled. The missing packets are handled by this layer because network layer is limited. They don't do the sequence of it or something is missing. They are only focused on the performance. Okay. Now transport layer. Okay. I know you can handle the performance, but I want to know it is actually delivered or no. Okay. And they can reorder messages and deliver duplicate copies of the same messages. Oh, if this one is received multiple times, then I can discard it. And limit messages to finite size. IP, in the middle guys, their packet size are standardized, meaning the size cannot be changed variantly. The size is only changeable in a higher layer. Even I have a bigger packet, what do I do to handle to net? I divide it to network size. Then 1,500 bytes, something like this. It's a standardized. Then they can deliver via router. Okay. So these packets, I do ordering. And even the packets are bigger sizes coming to a higher layer, I have a responsible to divide it to smaller size. Which one is proper size? And network layer is intended to hide different technology on a link level and provide transparent end-to-end routing. Meaning, if I send, meaning if I'm using Chrome, the other end should able to understand the Chrome. If I'm using TCP, the other end should be clearly understand my TCP. What do you call the corresponding layer should be encodable and decodable, and they are transparent each other. The goes lower, I don't really care. It is encapsulated and decapsulated, but same level, they should be available. They should be able to read it properly. Okay. Transport layer provides this TCP transport layer provides end-to-end transport system to application layer. Okay, so clear concept is end-to-end. So internet protocol, internet transport protocol, there is UDP and TCP and RPC and many. UDP basically best effort. Okay. TCP is a connection is a setup and discard the corrupted packets and retransmission of the lost packet. And they do also flow control. They do also control congestion control. What's the difference between flow control and congestion control? We're going to talk about this in more detail. And there is a remote procedure called RPC, meaning request and reply service. Okay, request my messages. Oh, here's my reply. Request something. Oh, here's my reply. So I may say R or query. If it is query, I handle different. If it is reception, meaning I have to act. Okay. So difference between flow and congestion control. The basic flow control, it controls the traffic from a particular sender to receiver. Congestion control is view of the network. How does it work in the network? How does it work in the end-to-end? Is flow control. Congestion control is in the view of network. It controls traffic entering network. And flow control, it controls traffic from a particular sender and receiver, which is the end-to-end. Congestion control is network itself. This is the one-to-one. In the middle, I don't really care. So what does it look like? How does it perform end-to-end? Keep asking. But this one, let's say is sender and receiver. In the middle, how this network handle, how this network digest and provide feedback. Oh, this network works in this way. So if you talk about view of the congestion control, that is network view. Flow control is one-to-one, end-to-end. The purpose of the flow control is it prevents the receiver from being overwhelmed. So I do care about your receiver. It prevents a network from congested. Oh, network is congested. Responsibility is flow control is responsibility handled by the data link layer and the transport layer. Congestion control is responsibility is handled by the network layer and transport layer. And responsible, and the sender is responsible for the transmitting extra traffic. And congestion control, transport layer is responsible for transmitting extra traffic into the network on receiver or network. Prevention measures. The sender transmit data slowly to the receiver. Transport layer transmit data into network slowly. Method is feedback-based flow control and rate-based control. Congestion control is the provisioning and traffic-aware routing and admission control. Okay. So both flow control and congestion controls are traffic control mechanism. The flow control is a point-to-point control mechanism that controls the traffic between sender and receiver. So if it is about end-to-end sender to receiver, we talked about flow control. If we talked about the overwhelming of the network, then we defined one as congestion control. So from UDP, so I think we can talk about UDP from next class. Okay. And we're going to talk about UDP from next class. Any question about today's class? No? No question? Okay. Then we will talk about more detail about UDP on the coming lectures. And based on 310, new protocol coming in, the homework is delayed. The new homework will be released on coming Monday. And I also have to prepare the guideline for the final project. So if you didn't, if your team didn't check out the SDR, please check it out at your earliest convenience. Then you need to warm up how to use them. Okay, any question? Okay, thank you guys.